Hello. In this video, we're going to look at work and energy, which is a crucial component to grade 12 physics and our understanding of the world around us. Energy is one of those things that flows everywhere and informs every single aspect of science whenever we're looking at it, whether we're talking about chemistry or biology or physics. All of this gets down to energy and how it moves around a system and how it's transformed from one form to another. So we're going to look at a simple kinematic definition of energy in this case. So let's take a look at our example. In this case, it's asking the question, how much work do they do? Work is a physics quantity which measures energy change. So our formula that we're going to look at, our very first new formula here, is work is the force exerted times the displacement or distance traveled. Okay? Right away, work is force times distance. This is a brand new formula which you should make sure that you know because this is very important here. With this formula, a couple things to note. Our units for work, that's work, and the units are joules or J. Force here, you already know what that is. That in units of newtons, and d is a distance or displacement, and that is measured in meters. So d is in meters, and force is in newtons. All right, one other thing to note is that only the force in the direction of the motion counts. So only force in direction of motion counts. So if you're pushing to the side on something and it doesn't move, you don't do any work. Similarly, this is displacement. I'm actually going to add in that's displacement. With the displacement, that means if I don't move something, I did zero work on it. This pen is there. In order to move it there, I exerted a force, so I did some work. If I move it back to where it started, the net displacement is zero, so my net work done is zero. Remember, work in a physics context is talking about energy change through motion, and energy change in particular, and this is a really different quantity than how much work did you do today. So we're looking at this here. Let's take a look at how this works. So a couple of things. Before we can get to using this formula, we need to actually find our total combined force. So we have two friends who are pushing on this truck here. Remember I said only force in the direction of motion counts. This friend here is wasting part of his energy pushing into the truck, and part of his energy is being used to move the truck. So we're actually interested here in this vertical component to figure out how much work he's doing. I need to figure that out. I have a handy dandy right angle there, and I've got an angle here. So this is going to be my adjacent. So I'm going to call this guy here friend number 1 and friend number 2. So right away, my first force here, I need to find my my vertical component. So that's going to be 500 cos 25, using cos because I'm looking for adjacent. 500 cos 25 works out to 453.15389 newtons. Why that many decimal places? Because I should use a lot of decimal places before I get to the end of my problem, so that way I don't end up with rounding errors. Great. Okay, so this here is a force in the direction of motion. It's going to be positive because it's in the direction of motion. Force in the opposite direction of motion will get you negative work. It's great. So this is going to be my first force. My second force is just 400 newtons. My net useful force in this case is going to be just these added together. So I've got 453.15389 plus 400, which works out to 853.15389. If you're doing this on your calculator, leave all the decimals in your calculator and go from there. That's awesome. All right. Now, what I need to do is, first off, I need to figure out my force, which I did. Secondly, I need to figure out my velocity. I have my velocity, and I need to figure out my distance. I need this part here. So I have a velocity of 1.5 meters per second, and I have a time of 15 minutes, which works out to 900 seconds. Remember, minutes, seconds, and kilograms are our standard units. Sorry, meters, seconds, and kilograms. Figuring this out, my distance is my velocity times time. That is a formula straight from your formula sheet and a really basic one from grade 10. Plugging that in, 1.5 times 900 works out to 1350 meters. And now I have my displacement and I can figure out the work done. So my work is my force exerted, my useful force, times the distance traveled. So my work is 853, and leave those numbers in your calculator. Don't round it off yet if you can. And that times 1350, which means my total work done works out to 1,151,757.75 joules. Bleh. Let's turn that into scientific notation. That's way better. 1.15 times 10 to the 6th joules. There we go. There's my final answer. 1.15 times 10 to the 6th joules. 1.15 million joules, which sounds like a big number, but is reasonable. If they're exerting that much force for that long, they're moving this truck. Great. All right, so what we have here is this is the useful force done to move this truck, the amount of energy done to move this truck. This is a new formula. Work is force times distance, and our work is the net energy change in this case. Hope this has been helpful. Have a great day.